Let's now learn about late start and late finish. To compute late start and late finish, we have to do the inverse of what we did for early start and early finish. Let me draw a very simple network diagram here. So for computing early start and early finish, we started from the beginning node and moved forward through more forward path to compute the early start and early finish until we get to the end. But for computing late start and late finish, we actually going to have to do the inverse of this. We have to start from the end and move backward through backward path to get to the beginning and compute the late start and late finish. This is called backward path. So let's see how does it work. What is latest start? Latest start is the latest time you can start an activity without delaying the whole project. This is very important to know for a project manager. You want to know how much time you have. You can put off and delay an activity without delaying the project. The formula for latest start is equal to the late finish of that activity minus t, which is the time that activity takes to be completed. So that means that we need to compute late finish first. So let's see how we can compute late finish. Late finish. What is late finish? Late finish is the latest time an activity can be completed without delaying the project. So to compute late finish, it depends on situation and scenarios that you may encounter. So let me demonstrate here using a simple example of network diagram. So in this scenario that you see here, there is only one activity or one arrows leaving this node here. So to compute the latest finish of this activity, because we only have one activity leaving out of the node that we're going to, so the late finish here is equal to the earliest start of this node. Okay, so the late finish, when you have only one activity or one arrow leaving the node that you're going into, the late finish of that activity is equal to the latest start of the preceding activity or the next activity. What if you had multiple activities leaving the node that you're going into? Let me demonstrate here. So suppose this is the node that we're going to. We want to find the late finish here. And we actually have multiple activities going out of this node. And each of these has a latest start. So latest start 1, latest start 2, and latest start 3. The late finish here, because all of these three activities, they need to start after this activity is completed. So this means that the latest finish is equal to the minimum of latest start 1, latest start 2, and latest start 3. Okay. So when you have multiple leaving arrows, the late finish for the arrows that enter that node is equal to the smallest latest start of the leaving arrows. Let's now do an example on computing late start and late finish. This is the same diagram, network diagram, which is for the project of building a new department for a bank. What you need to do is to compute late start and late finish. And what you need to do is to start from the end, node 6, and go backward and then compute late start and late finish and then add them to the little box that we created. But to do that, you actually need to have the early start and early finish. So I'm going to show you those information because we already have done it in the previous example. This is the early start and early finish. So please pause here. Start from node 6, go backward in all the passes and compute the late finish and late start until you get to the very beginning node, node 1, and you have computed all the late start and late finish. And after that, then come back to check your answer, the final solution. All right, so let's start from node 6. We start here and we move backward. The late finish for this activity, the latest activity, is actually equal to its early finish. So that's equal to 20. So the late finish and early finish of the last activity is equal to each other. Okay? And we know that the formula for late start is equal to the late finish minus t, and t is the amount of time that an activity would take to be completed. So this is the formula. Now that we have the formula, we can compute the latest start. So latest start for activity 5 to 6 is 20 minus t. T here is 1. So that's 20 minus 1, which is 19. So I'm going to put 19 here. 19. So as you see here, for this activity, the early start and latest start are equal, and the late finish and early finish are equal as well. So let's now move to the next activity, going from right to left. So I'm going to go with activity 3 to 5. So let's start with the late finish. The late finish of this activity, activity 3 to 5, should be equal to the late start of the next activity, which is 5 to 6, and that's equal to 19. So I'm going to write 19 here. Okay. So the late finish of the previous activity, which is 3 to 5 here, is equal to the late start of the next activity, which is 5 to 6. So now we have the late finish of this activity, and we can compute the late start using the formula. So late start is equal to late finish, which is 19, minus t, which is 9. So that's equal to 10. So I'm going to put 10 here. Let's now do the next. So we're going to do activity 1 to 3 backward. So the late finish for this activity is equal to the latest start of the next activity. So that's equal to 10. I'm going to put 10 here. The latest start is equal to, according to the formula we have, is equal to late finish. So that's 10 minus t. T here is 4. So that's 10 minus 4, which is 6. So I'm going to put 6 as the latest start. Now let's go to this activity, activity 4 to 5. So the late finish here is equal to the latest start of the next activity. So that means that the late finish is 19. So I'm going to put 19 here. And the late start, according to the formula, is equal to late finish minus t. So that's 19 minus t is 3. So that's 16. So I'm going to put 16 as late start. Next activity 2 to 4. So we're going to go back for it. The late finish here would be equal to the latest start of next activity. So that would be 16. I'm going to put 16 here. 16. And late start for this activity 2 to 4, we're going to use the formula. So using this formula, the late start would be late finish, which computed as 16 minus t, and t is 6, so that's 16 minus 6, which is 10. So I'm going to put 10 as late start. Now we're going to go to the next activity, and that's activity 2 to 5. The late finish here is equal to the late finish of the latest start of next activity, so that's going to be 19. So I'm going to put 19 here, 19. And the late start would be late finish minus t, so that's 19 minus 11. 19 minus 11, and that's 8. Now we go to the next activity, and that activity 1 to 2. What is the late finish here? So we have two activity going out of node 2. We have activity 2 to 4 with latest start of 10, and we have activity 2 to 5 with latest start of 8. So because activity 2 to 5 and activity 2 to 4 both need to start after 1 to 2 is completed. So they cannot start until after 1 to 2 is completed. That means that activity 1 to 2 should be the latest time that it can finish is the minimum start time of the next activity. So that this means that the latest finish of activity 1 to 2 is equal to the minimum of the late finish, the late start of 2 to 4. So that's the latest start of 2 to 4 and latest start of 2 to 5. The latest start of 2 to 4 is 10. So this is 10. And the latest start of 2 to 5 is 8. So this is 8. Minimum of 10 and 8 is 8. So I'm going to put 8 here. So the latest finish, the late finish for activity 1 to 2 is 8. And to compute the latest start, that would be 8 minus t, which is 8 minus 8, that's 0. So the latest start is 0. So the most challenging part here, I would say, is node 1 to is activity 1 to 2. And that's where the node that you are going to have more than one activity or arrows going out of it. And to compute the latest finish, it's going to be the minimum of the latest start of the next activities here. So that would be the minimum of 10 and 8. So again, every time that you want to compute the latest finish for an activity that is going to a node with multiple, that means more than one activity going out of them, this is latest start 1, latest start 2, latest start 3. The late finish for this activity is equal to the minimum of the latest start of the next activity. So that would be ls1, ls2, and ls. So we are done. We have computed all the latest start and late finish for all the activities. And if you actually look at the critical path, if you remember, it was 1 to 2 and 2 to 5 and 5 to 6. If you look at those, you're going to see that the late finish and early finish and late start and early start are equal. Again, for all activities, 19 equal to 19, 8 equal to 8, 8 and 8, 0 and 0. Okay, so for the critical path, the earliest start and latest start are equal. Early finish and late finish are also equal. But for other activities, they are different. So as you see here, these are different, these are different, these are different. And that's a good thing because we know that, for example, for activity 1 to 3, for this activity 1 to 3, you know that you can start this activity you can delay this activity for 6 weeks and still get the project done by the 20th week. But for the critical activity, you do not have any delay. You cannot delay the critical activity. You have to get them done on time. Okay, so we are done with this example. Here is a typed out version, a neater version of the final solution for this example. As you see here, we have computed the earliest start, latest start, early finish, late finish for all of these activities. And also you can see that for this challenging node, finding the latest finish, that was equal to the minimum late start of the next node, which is 8 here. So we computed that as well.